In section 3 and in section 4, we use the z-tables, which are the standard normal distribution curves. The z-tables are fine when we have large samples, but what happens if the standard deviation is unknown and the sample size is small? In this case, the standard deviation is a poor approximation to the standard deviation of the population. So if the population is normal, then the sample distribution of the mean is normal. That's the first tenet of the central limit theorem. So now we won't use the z statistic to get probabilities, we'll use the t statistic. Now don't worry too much because the difference between these two is not too significant. As the sample size increases, the t distribution, which is the blue line here, approaches the z distribution. The difference between the t distribution and the z distribution is the t distribution tends to have fatter tails. So if I want to capture 95% of the observations under the t distribution, I would have to go further from the mean. So the z distribution, for example, the confidence interval for the 95% confidence interval would be 1.96 standard errors based on the z distribution. It will be something more than 1.96 standard errors for a t distribution. There's a link here, and you can go to the link yourself, but this is what the link is going to show us. Grabbed the wrong one. So this once again is a Java applet that just shows us how the t distribution changes as the sample size increases. Now it uses the term degrees of freedom. Degrees of freedom is defined as the sample size minus the number of variables. Well, we only have one variable in this case, so degrees of freedom would be defined as n minus 1. So as we increase the degrees of freedom, you can see that the blue line, or the t distribution, approaches the z distribution. In fact, when our sample size is relatively small, so here's a sample size of 10, 10 minus 1 equals 9, the t distribution is really quite close. So you might argue, well, why do we even bother? Because when are we going to be using a sample size that is that small? Well, the reason we bring it up is because Excel always uses the t distribution. It always factors in the sample size when it calculates z-scores or it calculates probabilities. As the sample size gets larger, the t distribution gets smaller, and the t distribution approaches the z distribution. And we can see that when we have a sample size that is up, say around 90, 91, 100, we'll go all the way to 100. So our sample size is 100, so the degrees of freedom are n minus 1 or 99. That blue line is almost identical to the red line. And we can see that it approaches the red line. So that is the difference between a t distribution and a z distribution. Once again, to summarize, t distribution tends to have fatter tails, it has a lower peak, but as the sample size becomes larger, the t distribution becomes the z distribution. Now, from now on, we'll be using the t tables in the back of the book, and we'll recognize that Excel will be using the t distribution as well.